Hi there, welcome to this video on verified data. I've made a test page here for us to use, and you can see here I've said this page has one revision, and if we click on the VerifyPage extension, we can see there's only one revision here. Remember, you can always click VerifyPage manually to run those checks again. Now I'd like to talk a little bit about how we keep track of the history of documents, and we do that on the back end with a blockchain structure. That means that for each revision and change I make to the document, it's linked back to the previous revisions, and this is all done using the hashing, which is familiar to blockchain technology, and that means I can be really secure on the history of this document, that hasn't been changed. So if I click edit and I say this page has two revisions, then you can see I've now actually got two revisions. The first one where I created the document, and then a second one where I made the change. And the data accounting extension here in this case is telling me that these revisions check out. So the second revision follows on from the first revision, and the hashes match. The verification hash matches. So I know that this version of the document that I'm looking at is secure. Now I'd like to talk to you about the levels of classification that we have for verified data. So this one that we're looking at, we've just seen, is level 1 verification. We know that the integrity is verifiable. So I know, and by the way, I can do that on any of these pages, but when I say the verification hash matches, then I know that no one has changed this file before I receive it. But I can go further than that, and that's where we have account or time verification. And level 2 or 3, that's going to be determined by whether you've got just the account verified or also time. And let's go back and have a quick look at what that means. So the first one is time verification. Now I know that nothing has changed between these two revisions, but if I want to have a fixed anchor for the time at which this was created, that is made possible by this witnessing function that we have in the PKC. So I go to my witness page, and you've seen me do this in previous videos, but if I generate the domain manifest, which is a data fingerprint of all of the data in my data vault, you can see here verified data test. The page we're looking at is a part of this fingerprint. And now I go to domain manifest publisher, and I publish this fingerprint onto the Ethereum blockchain. Then it means that this verification hash, my overall data fingerprint, is somewhere in a public place where I can verify that immutably was the state of my database at that time. And that, by the way, is a service that typically a notary would perform for you at great expense, but you've just seen me do that very cheaply in a couple of seconds. Now, if I go back to my verified data test page, I click up here on my VerifyPage extension, and you see that my revision 2 now has this witness event verification. So the VerifyPage extension, that's gone online and checked the Ethereum chain to make sure that this page, this witness event, was really there. So it knows that this page was a part of that data fingerprint, and that's seen there. That's seen here. So as part of this revision, well, now we qualify for level 2 integrity. But if I want to go one level further, if I want to go one step further, what I'm going to need to do is sign it. So in some way, entangle it with an identity, which is mine. So if I sign it with my wallet address, then we know not only when this was written, so we know when the second revision was written, because we have that fixed to the Ethereum blockchain, but also by who. So we can see here I've got my wallet address that was used to sign the document. And again, if I go into my VerifyPage extension, here my second revision now has not only witness event verification, but also a valid signature from my wallet, which is 0xEF5B. Great, thanks for watching this video on verified data.